Thank you. It's really a pleasure to be here. As I told in my first session yesterday, it's my first time here in India, so I'm loving. By the way, the slides that I'm presenting here are available in this URL, okay? Just in case if you see something interesting, or if you see something that you want to share with your friends, with your colleagues that are not present in this conference, you can just get the slides. Think like an open source slides, okay? By the way, as I was introduced, my name is Rafael Benevides. I'm a Brazilian living in the United States. So English is not my native language. So if you want to do a question, if you want to make a question, please just speak a little bit slowly so I can understand. I started in Red Hat like 7 years ago. I was a consultant, then I moved to a software engineer role, and now I'm working as a director of developer experience. But essentially, I'm a Java developer. I like to develop a Java application just like as you. And given that DevOps practices are so important nowadays, I'm also very involved with containers. Okay? And let me also invite all of you to join the Red Hat Developers Program. I don't know if you heard about that, but please, this website, developers.redhat.com, contains valuable resources for us, for developers. There you can find free access to products, you can find free ebooks, you can find blog posts, articles, and in the future you will have also webinars. So it's good to sign up, and also if you just sign up and after the session you go to the Red Hat booth, you can get a t-shirt, a Red Hat t-shirt, okay? So it's great for us. But let me start with a story that happened in Brazil and when I lived there. One day I was at the zoo, walking there with my niece and my brother, my wife and my sister-in-law. And then my niece saw different animals, and she came to me and said, I've realized that every animal has a superpower. She's crazy about Marvel and DC superheroes. And so she came to me and asked, I saw that the birds can fly, the snakes have their poison. Every animal has a different superpower. And she asked me, what are the human superpowers? And I started to wonder about that. And the best answer that I could give to that small child, 4 years old, was that thinking is our best superpower. It's the best power that we have, because thinking has taken us to places that we never imagined before, right? And with thinking, we became problem solvers until we decided to become programmers. Okay, that's a joke. Well, so what happens once that we find a problem? Once that we find a problem, we start to think what are the best solutions, what are the causes and the effects to solve that problem. So once that we identify the problem, we also identify a solution. We tend to think that that's the best solution. But this doesn't stop there. Once that we identify a solution, we start to have a continuous improvement cycle to find also possible better solutions. This is a kind of feedback loop. And we need to understand that the feedback loop is so important in our life, because when we are learning how to speak, we depend on the feedback of our parents to know if we are doing the right grammar, the right pronunciation, right? When we are learning how to walk, we depend on the feedback of the gravity to know if we are about to fall, or if we are all walking the right way. So the feedback loop, the feedback that we receive is really important in our life in general. So once that we identify a solution, what do you think that we should do? Any guess? Yes, that's right. Share. You don't see that in the slides, right? In the online slides. Because when we share, we can have more people joining the feedback loop. We don't have the feedback only from ourselves, only from our parents or from all the colleagues, but from many people, for different people that we share that solution. And that was what happened to Heroku. Heroku is a company, it's a cloud provider, and they saw that different customers that tried to release their application on the cloud, they faced the same problems, and they find more or less the same solution. And what Heroku did was to collect those solutions and aggregate that in a kind of methodology that they called 12-factor. It's called 12-factor because it's 12 solutions, 12 like I could say 12 different things that you can do that will improve your application on the cloud. And what we will do today together, all of us, is go through each one of these factors and understand why they are so important for us. How can they solve our problems when we're trying to deploy an application in the cloud? Okay? These are the 12 factors. Okay? We don't need to memorize each one of them because we need to understand what problems they solve. Okay? The first one is called Codebase. It seems a little bit odd to have that name. Okay? The description is even odder because it says, one code base tracked in revision control, many deploys. But what does it mean? It means that if you have one application, it should be stored in one repository, and that replication will be packaged, and it will be deployed in many, it will cause many deployments. First, you will deploy that application in a development area. You will run your tests there. Then it will be deployed. The same package will be deployed it will be released in a staging area. You will run your integration test there to finally land in a production. But the question is, what it does not mean. For example, if you have one application, for example, you have one application that you deploy in a development area, but then you have a copy of the same application that you deploy in QA, in quality assurance, and then in production, because on this repository you store the security fixes, the bug fixes that you perceived or that you found in production, and you keep your development faster in another repository. That's totally wrong, okay? On those cases, it's preferable to have one single repo. And you can have different branches to control different versions, but please do not split in a copy of your application in different repositories, okay? Another thing that's I've seen in some companies, but please avoid, is to have one big master repo for every application. A big repository that store everything there. Application 1, application A, B, C, D, documentation, everything. So that's totally wrong. And this is what the Codebase wants to show us. And by the way, the demo that I will show you is stored in GitHub. Let me... So this is the application that we will work together to see the 12 factors. It's a single application that's deployed, that's stored in GitHub. The link is on the slides. I will show you later. But that will be used through the complete demo. Okay? Now, what about dependencies? Dependencies says that you should explicitly declare and isolate dependencies. That seems quite obvious, okay? Because most of modern languages, if you are working with Java, you have Maven to control your dependencies. If you are working with Ruby, you have the gems. If you are working with Node.js, you have NPM to control the dependencies. But the idea is that you will never store binary files, binary dependencies on your GitHub. Just the source code. The dependencies should be declared in a package or dependency management system, like these ones that I'm showing. And that will avoid a lot of problems, because I've seen in the past when people didn't use Maven, they downloaded, for example, Commons Lang 2.0, and they changed the name to commonslang.jar, and you didn't know what was the version. Then someone replaced that in the GitHub, in the subversion. That time was subversion or CVS. They replaced that by a new version, but didn't use the name, and it caused a lot of conflicts. So it's preferable to have something like Maven to control our projects. And we can see this in our application because it has the POM.xml here, where we can see the list of dependencies used. Okay, Burst Sutter from Red Hat made a lot of sessions, and Thomas as well, related to Vertex. This is a Java application using Vertex. So all my Vertex dependencies, including MySQL, the MySQL driver, is declared in the POM.xml. Okay, but to make our journey in the way that we develop application, instead of see the factor number 3 now, we will take a detour to the factor number 5. Then we will return to the factor 3 and 4 later, okay? So the factor number 5 says build, release, and run. The description says strictly separate build and run stages. But what does it really mean? What it means that every stage of your building cycle should be performed independently, okay? And of course, you could have, and it's interesting that you have a continuous integration pipeline that can perform every one of these stages in a single atomic operation, okay? But they need to be independently made, because each one of these stages produce a different artifact for a different reason. So, for example, what we will produce in the build stage, we will produce, for example, we are all Java developers. We will produce a WAR file or a jar file. Okay, who will produce that? A continuous integration tools like Jenkins, for example. Why we want the continuous integration to produce a WAR file and a jar file for us? Because we want to avoid it works in my machine. Because I've seen that a lot. People want to release in production, they make the WAR file, they export, they go to Eclipse or IntelliJ IDEA, and they export the project as a WAR file. Of course, in bringing all the dependence that the developer has on his machine, but usually that's not the case when it's running in production. Okay, so it's preferable to have an continuous integration tool that will build the application for you. In the next stage of the pipeline, we will release our application. And what we will release? We will release a container image, because with containers we can have faster deployments, faster updates, and even rollbacks. It's easy to manage an environment when we are deploying our application as a container. Usually that can be performed with a container as a continuous deployment or continuous delivery tool. Okay. By the way, Jenkins can perform both. They can build your software and also release your software. And then, now that we have the image, what we will do? We will execute our image in a platform like Docker or Kubernetes. Of course, Kubernetes provides us a nice orchestration tool. So I prefer to run this containers image in a Kubernetes/OpenShift environment. So let's see how that works. Because I have the application here. Okay. Let me just do a Maven clear to know that I'm starting from the scratch. Oops, Maven clean, not clear. Maven clean. Let me also increase the font size because I want that everyone can see. Okay, so the first thing that we will do is build our application, right? The build is just a plain Maven package that will download the dependencies using the dependencies that we declared on the POM. It will generate the jar file for us. And now that we have the jar file, we need to release it inside OpenShift. Okay, note here that OpenShift can store the image for us. So I have a place here to store the image, and I will release my software inside OpenShift. Remember, what's the release process? I'm releasing an image, so I need to upload the resources to OpenShift. OpenShift will read the Docker file that has on the repo. So you can see the instructions here, the Docker file instructions. It will generate an image and place it inside OpenShift, in the OpenShift internal registry. So we can see here, it has been published. I can see even the layers of this image. But I don't have the application running yet. I just have the image inside OpenShift. So the next step is run my application, is create an application using the image that I provided. Now let's wait for the application to become available. We can even open the pod here to see the logs. Okay, successful. I can open the URL and say, hello India, or hello GIDS. Yeah, my application is working. Hello from, and this is the name of the host, the name of the host of the container. You can see that's the same name of the pod. Okay, my 12 factor number 2, LMKQKY. Okay, so I have my application running. Again, it was 3 different stages. I made each one of them individually. I produced the jar file, I created an image, then I executed the image, okay? Let's continue. Now let's go back to the factor number 3. The factor number 3 says that you should store your configuration in the environment. Think in an environment like an environment variable, a properties file, a configuration file, because it means that if you want to change the behavior of your application, And to change the behavior of your application, if you need to repackage, you are doing something wrong. Okay? Remember, I just released the application once. And what I will do now to demonstrate this, this factor is to place an environment variable inside my OpenShift, inside the container, and that will cause my application to change the behavior. Okay? That's possible. In this case here, I decided to use environment variable. But again, you could use a properties files or a configuration file. So you can see here that in the environment, I don't have any environment variable. So let me perform a configuration here. Once that I declared that I want a new environment variable, OpenShift will take care automatically for me and drop the old container and create a new container. In fact, first, it will create a new container. Once that the new container is running, it will drop the old container. Okay, and that way I will always have my application available. Okay, so, and by the way, at 3 o'clock, 3:25, I will talk just about zero downtime deployments, covering things like canary deployments, blue-green deployments, rolling updates. In this case, it was a rolling update. So you can see here that it created a new version, my factor app /3, -3, and inside it has an environment variable called greeting. And the greeting says, hi name, my configuration has changed. Let's update. Yeah, hi GIDS, my configuration has changed. I totally changed the behavior of application, but I didn't need to repackage it again. Again, it's the same image that I released some minutes ago. That's true, for example, for database connections. That's true, for example, for feature toggles. Suppose that you want to enable a tech preview feature. You don't know if that feature will really work or will really increase the sales of your company. You can just place environment variable. Feature number 4 enable equals true. If that variable means it's equals false, so it's not present, that feature will not be part of your application. So that's why and how you should use the factor number 3 called config. So let's continue our journey to factor number 5. Factor number 5 is really interesting. It says that you should, the name is, again, all the names of these factors are really a bit odd if you don't understand them. The name is backend services. But what does it mean? It means that you should treat your backend service as attachable resources. So for example, today you could have a MySQL running on premise. But later, you should be able to change your application to connect to a MySQL running on Amazon or Google Cloud Engine, for example. That's even true, for example, for a volume. Suppose that today you want to store your log files in a specific volume, but maybe the logs start to increase a lot, and you decide to move that to an NFS volume. Okay, you should be able to perform that again without needing to repackage your application again. Or, for example, suppose that you want to consume Twitter API. So everything that's not your application should be treated as a attachable resource. You should have a way to know where it's available and when it's available, okay? So for now, our application is not connected to any database. What I will do now is release a database and say to my application, my database is running in that host, it uses that password, so it's a mix of attachable resources plus configuration, okay? So let's do the factor number 4. Let's deploy a database here. Remember that now that I have a database, I need to create a new deployment of that same image, because that image will contain the connection information of my database. Let's see. Container creating. Okay, and inside my application, I have new environment variables, saying the host name, the password, and the username. But let's try to access. Okay, at least it's connecting to the database, but it's not bringing anything because I haven't populated my database yet. So let's populate the database. Okay, refresh, connected. Okay. So this is how I can attach a resource to my application. Again, I didn't make any new deployment. I just packaged once, released once, but I executed many times in the same environment. By the way, this is my dev environment. You can see by the name of the project is 12-factor-dev. Let's continue. Our journey now stops on processes. What does it mean? Process can mean anything. It can, or many different things. But the descriptions give us a tip. It says that we should execute the app as one or more stateless process. 12-factor processes are stateless and share nothing. Here, it's a little bit tricky when people think about state. They tend to think about state like, for example, it means that my data, it means my HTTP session. Well, for example, you should store everything. It says that you should store everything outside your application. Because your application, you saw, I've made many deployments. But if I was using an HTTP session that stores the session inside my application, I would lose that every time that I deploy. So it's good to use a mechanism outside of my application, like InfiniSpan or Redis. Okay, if you want to store state, we could store in one of those backend services on a volume or in a database, okay, but not inside your application. Usually, when we are developing REST APIs, for example, we tend to do stateless invocation, okay? So please continue to do that. Avoid holding any kind of state on your REST endpoints. Let's talk about port binding. Again, the name is a little bit odd, port binding, but it says that you should export your service through port binding. In that, it's a really good match with containers, because when we are playing with Docker, for example, we never, of course, we could do a -p and specify the local port and the container port. But that could cause conflicts, for example. Or even, for example, imagine a situation that we want to connect our application to a database, and the operation guy provides an installation of MySQL running on the port 3306. Later, we ask him, can you install another database because I need another database and blah, 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 blah. And he says, okay, I just have one server and I cannot run two MySQLs on the 3306, so I will run that on 3307. If your application is not prepared to that, you will very likely have a problem, okay? So that's also, this factor also matches with the factor 3 configuration. We should never depend on the port number. Question? What is it trying to solve? Well, this is what I was explaining. Sometimes we can't control how many instances of a database we'll have on a specific host, okay? Or if we are using container and we just run that with Docker with capital P, Docker will assign a random port for you. So it's not good for your application to depend on the specific port. In a container world, we have always the application running on 3306, but we could also have the container assigning a different port for us. So our application needs to know what is the real port. For example, suppose that we are running a Wildfly or a Spring Boot. It usually runs on port 8080, okay? But we want to export that to allow users to access on the port 80. So we could run our container saying, okay, this is a mapping between the port 80 to the outside world to the port 8080 inside the container. So we shouldn't, the idea is never depend on the port. So you're saying externalize this kind of thing? Yes. How you can do that? Again, with configuration. You can export the service port to the application that's consuming a service. By the way, Kubernetes, depends on some people pronounce Kubernetes, other people pronounce Kubernetes. The fact is, Kubernetes controls that for you. If you, for example, let me show you something. Here I don't have any. I opened a terminal. Okay. I will execute grep MySQL. I have an environment variable saying that MySQL, the service is running on port 3306. Because if I take a look here on MySQL, on the deployment, on the service, I mean, there is a mapping, a direct mapping to the port 3306 on the service port to the target port 3306. That's fine. But suppose that I need to change the port. This is what I will do now. I'll change that to the port 5000, just like the slides. Okay? So a new mapping has been introduced. Now I have the port 5000 mapping to the container port 3306. If we go to our application that just had a new deployment, we have the port 5000 inserted here in the configuration. I can run the same command again, set grep MySQL. And now I can see that the MySQL service port is still 3306, but it has also the port 5000 included on that. But again, how it knows that's running on port 5000? Because I specified here in the configuration, and my application is still, let me do it here, is still working and connected to the database. To prove that, I can even come here in MySQL and erase the mapping. Okay, I have a mapping here. Let me edit the YAML file. I can remove this mapping. Save. I just have now port 5000 to port 3306, and my application is still running. Okay? So I'm not really attached to the port of the service. So it gives also flexibility to people on the operation to change my application to another host, to another port, based on their needs, based on security constraints or firewall regulations, whatever, my application is still the same. Okay? Again, I did not deploy, I didn't package my application again. This is a 12-factor app that's trying to use all factors without needing to repackage the application. So let's continue to the factor number 8, concurrency. Scale out via the process model. I like to say that this factor is the best advocate for microservices. Because, for example, it says that you can scale up and out your application. But to be able to do that, your application should have different modules. Okay, so if you have an increase on the sales, you don't need to scale everything, scale the finance and the data warehouse, or you don't need to scale everything. You can just scale what has a need to more instances. You can just scale the sales part, the sales module, or the sales microservice of your application. Okay? So that's the idea. So let's see how we can do that with containers and with Kubernetes and OpenShift. So I have here just one instance responding to this URL. And what I will do now is scale that to have 3 replicas running. Note here that once that the server becomes available, I have now one instance, the other 2 are starting. Once that they become available, you will see that I have now, let me wait a little bit. It will have a new response there. Okay, you can see here. A new server, and a new server has been included on the response. Okay, so it was easy to scale. I can even come here to my dashboard and click on these arrows. Let me just remove this here. Now I want 5 replicas. It's easy like that. And it should be also easy if I have multiple services. I'm using OpenShift. OpenShift is an enterprise distribution of Kubernetes. It runs on top of Kubernetes, so that's why the concepts are the same. That's why you have pods, that's why you have services. Okay, the YAML file is just like the same. So it's basically Kubernetes running on an enterprise distribution. Okay, so by the way, if you want to see, Red Hat OpenShift. OpenShift is a Red Hat PaaS that allows developers to quickly develop, host, and scale application in a cloud environment. So OpenShift uses Kubernetes, so I have here the version of Kubernetes being used. So I have now 5 replicas responding. To scale down, it's easy as well. I can just say, okay, I want 3 replicas, and it will kill the 2 trailing replicas, and now I will have just 3 again. So it's easy. What I want to show you is that the 12 factors plus containers, they are a good match to be fulfilled. You can fulfill the 12 factors using containers and CI/CD pipelines. Okay? Sorry? Sorry, I can't hear you. Yeah. Yeah, it's the same image that it created 3 or 4 or 5 replicas. Yeah, one of the idea of Kubernetes / OpenShift is that you can create a cluster of nodes. So here I have a dashboard, but I could have this container running on 100 machines. For example, suppose that I have 100 machines. Kubernetes will choose one to run on one container, another one to run the other, another one to run the third one. Yes. Yeah. In this case, I'm running on my machine. Okay, so I just have one laptop here. It's running everything on my machine. But if I was running in a cluster, in a real cluster with more machines, Kubernetes would take care for me of the resources. It will take a look on the nodes and say, okay, can that node has available resource to run that container? Okay, it has, so I'll run my container there. So that's what Kubernetes does for you automatically. You could, of course, use Kubernetes to say, okay, I want to run all my production containers on those hosts, all my development containers on those hosts. That's also possible. Okay, so the idea of Kubernetes is to manage and orchestrate container for you. Okay. You mean during an update? Yeah. The architecture of Kubernetes is based on masters. You can have one or more masters because sometimes you need to update one by one. And multiple nodes. So even if you have no masters running, if you shut down them, the containers will still work on the nodes. Okay? When the master returns, it will return to manage those containers. So the architecture allows you to do updates and keep the containers running on those hosts. Okay, so let's continue to factor number 9. It means disposability. Maximize robustness with fast startup and graceful shutdown. The best way that I like to explain this factor is through the concept of pets versus kettles. Have you heard about pets versus kettles? Well, the idea of pets versus kettles is that we treated our servers for long times as pets. For example, we give them names. If they were sick, we took them to vets, right? So imagine, for example, in your company, probably there is a server there with a name. I saw companies using name of planets, name of cities, capital cities. I've seen using the name of stars, name of different names. And once I worked in a company that they used name of philosophers. And one day I started to work. I arrived at work 8 o'clock in the morning, and the sysadmin was crying. And I asked, why are you crying? And he said, Plato has died. And I don't know who was Plato until I figured out that he was talking about the server. So for many years, we treated our servers just like pets. And the idea is to treat them as a cattle. As for example, it doesn't matter what is the server name. It doesn't matter how long it's up and running. We just need to be able to replace them easily. Okay? So that's the idea of disposability. And with containers, we can do that. With containers, if the container dies for any reason, we can do just like any kind of cattle. We just replace them by a new one, and that will be fine. Okay? Of course, during this process of being offline, we should be able to recover our application very fast. So let's show how we can demonstrate this factor, number 9. So as you can see, I have 3 replicas running. And what I will do now is shut down 2 of them. Okay, I destroyed 2 processes. Now I have just 1 process replying, but Kubernetes detected that 2 nodes are down, and it will bring those nodes, those pods, fast to me. Okay, so let's wait. 1, 2, and now we have again 3 pods, 3 new replicas running, responding on that same host. Okay, again, I'm not using here a stick session. I'm not attached to the same session. So every request that I do on the same URL will land in a different replica. So again, let's kill. So I have 5 now because once that it detected that the server is down, it will automatically discard those servers that are not working anymore and bring more 2 live. This is one of the beauties of when you are using an orchestration tool like Kubernetes. You say, I want 3, and for any reason, if one of those 3 dies, it will bring it again, a new replica. It's just like a new boot of the application server. So you don't need to start your application manually. You just say, I want 3, and it will keep running 3 for you. And always a new tree. Always a new replica. Factor number 10, dev to prod parity. Keep development, staging, and production similar as possible. Because we want to avoid it works on my machine. By the way, another story. I worked in a company many years ago that there was a guy that was responsible for an application, and every time that his phone rang, I looked to a colleague of mine, and we started to count how many minutes. It was a bet. So sometimes I told him, I bet that he will say it works on my machine in 1 minute. And he would say, okay, I think that this time he will take 3 minutes to say that. Because every time that someone called him, he said, it works in my machine, it's not my problem, and hung up the phone. So we want to avoid that. And again, the only way to make that possible is using a continuous deployment, a continuous delivery tool, a continuous delivery pipeline. Because we want that once that we have a code, we push that to a version control, Git, Subversion, CVS, no, please, CVS, no. We will have the continuous integration pipeline building that code, packaging, running the tests, deploying that, and now that we have the same image, we can move the image from development to staging. Now we run all the tests on the staging area. Now, once that we know that's good, we get the same package and move that to the production. There will be no difference in environment because it's everything packaged in your container. Your container contains your Linux kernel, your file system, your environment variables, your JDK version, your application server version, everything that was tested will be the same thing that will be released in production. So until now, everything that we've done here, it's running on the development area. Let's take a look on the image again, just to take a look. My image, my 12-factor app, has the hash 2BFC7E. Of course, it's a long hash, as you can see here. Yeah, it's a long hash, but we just need to know that this is the hash, this is the identifier of our release. And it's a good practice as well, because sometimes we can have multiple images created with the same name. Demo 1.0, demo 1.1, and have it created many times. But we cannot fake the SHA-256 of the image. So I saw some companies, when they homologate the version that will be released in production, they usually get the SHA-256 and write, this is the version that's going to production. If there is any change, it's not the application that has been tested and homologated. So okay, I have this version here. What I will do, look, all projects are here. I will deploy the same image to a staging area. So it's the factor number 10. I'm deploying to the staging area. It's created a staging. Let's open. And let's take a look on the image. I have here on my staging area the same hash. It means that the same image has been moved from the development to the staging area. I didn't package my application again. I didn't release my application again. It's still the same image. Now I have it running in a staging area with a different name. You can see here, dash staging. I can test it. And my application is working. I can say, hello, India, on this URL, 12-factor-dem-staging. Again, the same application. I didn't run Maven package anymore. And it's running on staging. Now let's go to the factor number 11. Factor number 11 means, tells us that we should treat our log as event streams. Because in the past, we used log4j, commons log, and different APIs to control the log. The developer was responsible to treat the log, produce the log, to give the format, to decide if it was a file, if we would store in the file or just produce in the console, and the rotation of the log. In a 12-factor app, or when it's running a container, we should always produce the log to the console, and then if we want to treat that log for any reason, we should have sidecars, something externally to our application that will consume that log. Think, for example, of a stack like Elk, Elasticsearch, Logstash, and Kibana, or EFK, Elasticsearch, FluentD, and Kibana. So if you want to store your log, you can have something externally that will consume that log and store. If you want to analyze that log, you have something else that will connect to that stream, consume the log, and do what's needed with the log. Okay? And again, that's really simple with containers. With containers, we can, it's automatic. Everything that's running in a container produces a log for you. And if you need, you can just connect an application and consume that logging. So for example, let me get here. I saw the logs in the console. I can even come here in the OpenShift in the OpenShift dashboard. I have a tab here for logs. I can see the logs of my application. I can even click follow to keep seeing the result. Let me, hello. Yeah, I can see the logs here. So, but don't be thinking about producing the log. Because an example, I have here 3 replicas, right? Each one of these replicas are producing different logs. How do you know that something wrong is going with your application? Suppose that you have 100 replicas running. So again, it's good to have a log monitoring tool like Elk Stack or EFK Stack that can consume those logs and allows you to analyze, search, aggregate. And finally, to complete our journey, let's talk about admin process. Run admin management tasks as one-off process. I don't know how many of you have opened a shell in a container, but if you do a PS AXU, you see that the PID number 1 is always the process of your container. The other 2 processes that is available here is the shell and the PS process that I just executed. So the container automatically runs just one single process each time. Of course, you can attach other processes, but the idea here is, sorry, suppose that I want to do a management task. Suppose that I want to do an update or to do a thread dump. We solved some some sessions that talks about JVM performance. Sometimes you need to do a thread dump. And of course, that could impact your application. There are some things that will impact directly your process. So in those cases, it's preferable to have an attached process that if something goes wrong, if the CPU usage or memory usage is increased, you can just kill that process or create a kind of limit for that process that will not affect your main process. And how you can see that in a container, again, is open a parallel process. Like for example, I can open a bash process in my container and do any kind of task that I need, or any kind of maintains job or process that I need to do. Okay, but again, it's a new process. It's a shell process, and I'm not messing with the process of the container that has its own CPU and memory usage. Okay. With these 12 factors, we completed our journey. Well, we could see that's not really focused on a technology. It's not focused on Java or PHP. It's totally agnostic of technology, but it can be very well satisfied with containers, as you could see. I use containers all the time. By microservices, because I can distribute my load, and with CI/CD pipelines, because I just want to produce to release my application once, and everything else will be made through a pipeline. Okay, those stages that I did manually could be performed by Jenkins in a pipeline that runs several stages. It's very focused on DevOps. And if you want to know more about the 12 factors, you can go to the 12 factor URL, which is 12factor.net. There it contains all those factors that we saw, and plus you can open it and see a detailed explanation. And if you want to try that same application, it's available publicly, and it's an open source application that's stored in GitHub. So, any questions? Yes, it's there. So let's open here. And by the way, the shell scripts are numbered according to the factors. So it helps a lot. Auto-scaling is a feature of Kubernetes. So you can say, for example, you can create a trigger of, for example, if the load of the container goes more than 80%, scale one container each minute, or one container each hour. And so this is the kind of policy that you can create to have an auto-scaling. Because what I did here was manually, but you can have it. Sorry. One repository, one application. It's preferable to have separated repos, because if you treat your application as microservices, it's good to have one repo for each microservice. Yeah. Okay, by the way, people, thank you so much. Don't forget to register. And by the way, my Twitter handle is @RafaBene. Thank you.